All right, so in Chapter 10, these are the last three sections we have. So this exam, which we're scheduled to take week after next, I hope we can keep up with that pace, is going to cover 5.5, 5.6, 5.7, 5.8, as the schedule says, 4 sections in Chapter 5, and now 3 sections in Chapter 10, 10.2, 10.3, 10.4. These are all parabolas, ellipses, which are like egg shapes, and hyperbolas, which are 2 branches turned away, either up, down, or right, left. So 3 geometrical shapes, basically. They're technically called conic sections. Anyway, so let's start with parabola. You guys know parabola. That's like, like the U-shapes we're used to, y equals x squared kind of thing. We've done parabolas, right? That's the same thing we're doing here. We're just going to get more specific in this section about the parabolas. That one is y equals x squared is a parabola. It's the most basic parabola. We're going to get more specific. What do I mean? Well, we're going to have them go up, down, right, and left. We're going to let them go all 4 directions. And we're also going to talk about something inside of them called their focus point. They have a focus point. We'll talk about some real-life applications of parabolas and actually solve some as well. And we'll also move them around. So we'll just go parabola crazy. So we'll take our basics and get really, really specific about parabolas. Okay, so the first thing to know and to have on your 3x5 card is the directional information about parabolas. Let me just get a fresh screen for that, in fact. Let me write this out. This is what you guys want to write down for sure on your 3x5 card and in your notes today. Let me give you the 4 directions. If you get this, most of the battle is over for parabolas. So parabolas can go up or down or right or left. And what, in the equation of a parabola, what determines which way they go is the first power letter. So, let you copy that down. Which direction is this first parabola going? He's going in the positive y direction, isn't he? Everybody say he's going up? What direction is the second parabola going? Yeah, negative y direction, down, huh? What direction is the third parabola going? Positive x direction to the right. And what direction is the fourth parabola going? Negative x to the left. Well, that tells you the equation. What do I mean? I mean the equation setup, the model, the template, is 4ay. It's positive 4ay for the first one. For the second one, it's negative 4ay. For the third one, whoops, it's y squared. Whoops, kind of scribbly there. Is positive 4x, and for the fourth one, it's y squared is minus 4ax. So let me let you copy that down. That's the most important thing I'm going to say about parabolas right there. That's the most important thing, is getting that basic equation down. Let you copy that down. Good to there? Okay, so, and the A is kind of funny, huh? Like, what is that little A? The A is how far to the focus. So let me add that to the picture. I think that'll help. The focus is always inside the parabola. So the A, it's how far from the center down A to what's called the focus point. Oops, didn't mean to do that. So that's the focus point. A is focus point. Now, what do we mean focus point? Well, let's get real with this, and I think even right now, even before we're into the details, I think it'll help. Satellite dish on people's roofs. Have you ever looked close at a satellite dish? You probably noticed. Satellite dish. It has like a little item, a receiver, that's held by a couple arms like that, sort of in the middle, inside of it like that. That receiver is located right at the focal point for a parabola. Oh, and satellite dishes are parabolic curvature. You know, there's different bending rates. There's different way, there's circular curvature and there's all kinds of curvature. You want to start thinking that way as you're moving on into higher math now. There's different kind of curves. There's different rates in how far they bend. And parabolic curvature, parabolas, are bent, they're curved at just the right bending rate so that they will aim all beams from outer space, from satellites, onto that focus point. What do I mean? So the satellite beams things in, it hits the curve, and the curve bounces it right to the focus point. No matter where the beams come, no matter where they hit, all the curvature is aimed to send everything bouncing right to that focal point. That's why it's called the focus point. Yeah, it's the same thing as a flashlight or searchlight or headlights in your car run backwards. So headlights in your car, flashlight, they put the lamp right there, shine it back on, the light shines back on the mirrored parabolic surface. That's right, flashlights, headlights, their curvature inside is parabola, and it shines out the other way, it just runs it backwards. Exactly. So parabolas are used a lot in real life. So all kinds of searchlights, flashlights, headlights, and then also satellites. The curvature is just perfect so that beams coming down, focus, aim, everything that. So engineers calculate where to put that focal point based on how big the parabola is and the curvature of the parabola. They calculate, and we will today, calculate where that focus should be located. That's how, then they put the arms right there to hold it right in the right spot. That's how it works. Also, if I throw something, right, if I take my eraser and I throw it, right, what just happened? It just did an arc like that. That arc, that curvature is exactly parabolic curvature. It's a parabola. It's not just any old kind of curvature. It's exactly a parabola. And so when the military launches artillery, all those calculations are parabola equations. That's what they do. If you hit a baseball, tennis ball, golf ball, all those arcs can be calculated as parabolic. That's what physics uses to calculate those arcs. Those are parabolic curves. So, a lot of real-life applications of a parabola. So, getting back to the formula then, let's get going with the formula. Main thing to notice then, the unique characteristic of a parabola is it has one letter squared and one letter first power. Do you notice that? See how it has one squared, one first power? That's different. The other two we're going to do next week, ellipses, which are egg shapes, and hyperbolas, which have two branches, up, down, and right, left. Those have both letters squared. So they would have x squared and y squared. So if you see an equation that has both x squared, y squared, it's not a parabola. So the unique characteristic of a parabola is it has one letter squared, either x squared, y to the first, or y squared, x to the first. It always has one squared, one not. Okay, and the one not is the direction. Is everybody seeing that? The first power letter, not the second, but the first power letter, positive y, up. Negative y, down. Positive x to the first, right. Negative x to the first, left. So the sign and the first power letter tell the direction. And then the A is how far to the focus point, from the center to the focus point, always inside the parabola. All right, so there's the basics. Let's get back to the problem then. So with that in mind, this should be easy. Look at that parabola. It's going up. It's a parabola going up. So what is the basic equation? Let's write out the basic. Is it y squared is 4ax, or is it x squared is 4ay? How do we know? Well, it's going what direction? Positive y, huh? So it's this one. First power letter, positive y. Remember, it's the first power letter that tells the story. So it's not this one, it's this one. So right away we know, forget this, huh? It's either this one or this one. We good to there so far? It's x squared equals something with a y. Right? Now, we don't know what the A is, we don't know where the focus is, but what can we do to figure out which one of these is right?
Well, the thing's really spread out real thin, plus it has the...
Plug in the point. Plug in the point. 125 is your x and your y. So, is it really this one? I don't know. Let me plug in the x and the y. So in the x spot I put the 1. In the y spot I put the 1/25. 1 equals 1. That's the 1. That's the winner. Does that make sense? See how it worked? Whereas if I put 125 over here, it wouldn't work. Say 1 squared is 125 times y. Y would be 125.
It'd be 1 equals 150.
They're multiplied. 625. But anyway, it wouldn't work.
Either way,
Is that good? That wouldn't work. Right? So that one's not true. Everybody with me on that? We okay? The answer is C? All right. Okay, let's try this one. So, so based on the direction, which way is this thing headed? This way, which is, it's headed this direction, which is what? Isn't the x-axis here? That's negative x, right? Isn't that negative x to the left? So negative x, so we know the equation is y squared equals minus 4ax to the first, right? The first power letter. So, which of those have negative x to the first? This one's got positive, he's out. This one's got y to the first, he's out. Y to the first, he's out. This one's positive. See how I'm eliminating them all? This one's y, this one's y. Okay, we're down to G and H. They're the only two left. They're the only two that have negative x to the first, negative x to the first. Good so far? Now, how do we know which of those is right?
orientation.
Let me give you some information about the center now. Is everybody good? Am I going too fast? Everybody good with there? See how it's either G or H? Because it's going left, so it's negative x to the first. So it's got to be G. They're the only ones that have negative x to the first. All the rest have y or they have positive. Okay. So now, which is which? Let me help you with the center. The center, which in this one is right there, negative 1, negative 5, in the equation always has opposite of both in parentheses. In other words, you're going to have, this is the x, this is the y. You're going to have parenthesis x plus 1. You're going to have parenthesis y plus 5. That's for all the equations. This section and the other two, which we'll do next week. Every one of these picture things we're going to be doing, you can know this and count on it. That when they give you the center of the shape, you can always go opposite, opposite. You can just look at the x value, the y value, and just go opposite, opposite in the parentheses next to x and y. It'll always be that way. And so which one of those has x plus 1 and y plus 5? H. There's our answer. It's always opposite. Opposite, opposite. Why? Why is it opposite? Because that's what makes it 0, 0. That's like the 0, 0, isn't it? That's like the center. So if you put in negative 1 for x here, see how that'd make that 0? And negative 5 for y, that'd make 0 equals 0. That's like the origin. Makes sense? That's why it's always opposite. It'll always be opposite in the parentheses in the equation. Good? So move on. These be pretty quick on that. Yeah, Michaela.
How would we find the equation if it wasn't multiple choice?
It'll be multiple choice. I'll give you more as we go. We'll get more information as we go. All right, let me let you try. Look at the direction. Think about which one it's got to be. How y'all doing? What y'all think? So it's going up, so that's positive y to the first. We good there? First off. So forget A, because A has a negative. Forget B. Forget all these negative ones. It's positive. So forget A, B, C, and D. They all have negative. No way. It's positive y. And then forget F and forget G because they have x to the first. Remember, it's all about the first power. Don't look over here at the second power. Look at the first power letter. It's always about the first power letter. Positive y to the first. So it's either E or H. Good so far? They're the only ones that have positive y, positive y. Positive 4y, positive 4y, right? Now, which one is it? Well, we got 3 and 5. That's x. That's y. Remember, it's opposite, opposite. So it's got to be x minus 3, y minus 5. So it's always h. At least it has been twice. Good? I move on there? Questions on that? Okay, so the graph of the parabola, there it is. Okay, so let me let you start. So go ahead and start with the direction. Think about the direction. It's always your first thing is which way is it going? Which way do the branches open up? And then write what that means about the equation. And then you've got a point on the shape, right? 25, 1, so you can plug in that point. Because you should be able to eliminate it down to 2 options by the direction. And then just plug in to know which one. So it's going positive x, right? The branches are going this way. Positive x. So that's y squared is positive 4ax. Is that good? So forget this guy and forget that guy. Good so far? We're down to 2 options. Because it's going in the positive x to the first power direction. So it's got to be either positive 25x or positive 1/25x. Now how do you know which one? Well, this is a point on the shape, so it's got to make the equation true. So just plug it in and see. That's x, that's y. So if I put in for x, what is it, 25, and I put in for y, 1, does that work? I think so. So 1 equals 1. Yep, A it is. That works. It won't work for C. If you tried C, if you put in for x, what is it, 25, and for y, 1, 1 squared would not equal 25 times 25. No. So it's A. We good?
Slope too, right?
What's that?
Slope?
It's not slope. Remember, slope would be for a line.
Okay.
These are curved.
That went.
So that's not slope.
Okay.
That's a fraction, but it's not slope. Slope would be for a straight line shape on that. Good on that? Other questions? Okay, so yeah, now we'll come up with the actual equation. Like Michaela was asking, how do we come up with the actual equation? So now I'll be able to show you the whole thing. Let's do that. So first off, let's just put they're going to want a picture, and pictures are helpful. Focus point is at -3, 0. So I encourage you to draw this with me as we go. This is exactly how you'll solve these. Pictures are very, very helpful. So focus point -3, 0. 1, 2, 3. So there's the focus point, or the A, huh? That's the A. Well, the A is how far to there? Okay, the vertex. Vertex is a fancy word for center. Vertex means center. So the vertex of a parabola means the center of the parabola. So the center is 0, 0. It's right here. So which way is this parabola going? Up, down, right, or left? It's got to be going left, doesn't it? It's got to be going like this. How do I know? Because the focus is always inside the dish, the satellite dish, right? Good so far? Now from that, can you write the equation? Try to write the equation now. Now that you have the direction, that should be a big help on the equation. So the equation, which direction is the parabola going? Negative x direction. So it's going to be y squared is minus 4ax. We good so far? Negative x to the first power. Remember, the direction always tells you the first power letter. Not the second, but the first power letter. Negative 4ax. Now, what's the a? Remember what a is? It's how far from the center to the focal point. So a is 3. Now, if you want to call a -3, sure, it doesn't really matter. Can we just all agree there will be a negative sign in the front one way or the other? Whether you say the negative is on the 4, or you say, no, I just want to make it a regular 4, and then I'll put the negative on the A. Okay, whatever. In the end, it's negative. That's all. It doesn't matter how you get there. In the end, it's got to be negative, whether you call the A negative. What I do is I just always say A is the distance. So distance is always positive, and it's going left. So whatever works for you. It's got to be negative in the end. So there's the equation. So yeah, that's why it's A. Is that okay? A is the distance from the center to the focus point. It's how far to the where you put the little receiver in a satellite dish. That's what A is. That's what the A means in the parabola equations. Good on that one? All right. Okay, yeah, they want something called the Latus rectum points. It sounds medical, but it's not. It's 2 points. Let me write a definition for you. So the Latus rectum points, they are 2 points at the focal depth 2A, double from the focus. What does all that mean? Let me show you what it means. It's pretty easy once you get the hang of it. So what I'm saying is the lattice rectum points, it's this point and it's this point. See, they're at the focal depth. So like if this is a satellite dish and this is where you're putting the receiver, the focus point, then at that depth or height or whatever you want to call it, at that level, it's the 2 edges of the parabola at that level. And where are they? They're always 2A, double whatever A is, twice as far as how far to the focus. What's A? A is 3. So this means this is up 6 and this one's down 6, double the 3. Does that make sense? Lattice rectum points are always double the focus. So that means the coordinates of this point are back 3, up 6. And the coordinates of this point are back 3, down 6. Those are the two. So they want the upper here. The upper would be the back 3, up 6, and the lower would be the back 3, down 6. They want the upper and lower lattice rectum points. So they're just at the focus level, double the focus distance to the edges. It's just a good way to know how wide the thing is. It's just a quick rule for how wide or narrow to make the satellite dish, the parabola. Good, and then they want the graph. We got the graph, so we're done with this problem. Questions on that? All right. Now they're going to give us something called, they're going to talk about the Directrix Line. Okay, let's start by drawing what we've got here. So the focus point on this one is over 0, up 6. 1, 2, 3, 4, 5, 6, right there. So there's the focus, over 0, up 6. The Directrix line, which I'll explain in a minute, it's always the line behind the parabola. That's at y equals -6. What's that? That's a line. It's not just a point. Notice it's a line. It's a straight line going through the y-axis. This is the y-axis. This is the x-axis, right? Going through the y-axis at -6. So 1, 2, 3, 4, 5, 6. So right here is the Directrix line at -6. Are we good to there? Now, what is that thing? That's the line directly behind the parabola. So, for example, whenever you have a parabola, say you have a parabola like this, you have a focus point inside and a Directrix line behind, and they're equidistant from it. In other words, the parabola's right in the middle of the two. Parabola's right in the middle of the Directrix line behind it and the focal point inside of it. If the parabola goes to the right, focus is here, Directrix line's back there. And the parabola's right in the middle. If the parabola goes left, focus point's here, Directrix line's over there. If the parabola goes down, the focus point's here, Directrix is up there. Does that make sense? The Directrix is always right behind the parabola, kind of directing it from behind. And the focal point is inside, and the parabola sits right in the middle. The parabola is always right in the middle. The center of the parabola is same distance to the focus point and Directrix line. It sits right in the middle of the two of them. They together direct the making of the parabola. So, if this is the focus point at up 6, and this is Directrix Line at down 6, where's the center of the parabola? It's right at the origin, because that's up 6 and down 6. It's always right in the middle, isn't it? Now, they'll be more tricky than that. In a minute, they're going to start moving them. So far, notice they've given us parabolas that are always anchored at the origin. Well, we had one that had been moved, but we'll have more. It's going to get more tricky in a minute. They're going to start moving them. So right now, that's centered at the origin. Which way does it go? Up, down, right, or left? Which way does it open? Does it open up or down or left or right? It must be up, huh? Because the focus is always inside the satellite dish. All right, and where's the latus rectum? Always 12, double the focus. So it's at the focal level, always double. So if the focus is 6, this will be over 12 this way, back 12 that way. There's the two latus rectum points. So the coordinate system would be over 12, up 6. This one here would be back 12, up 6. There's the two latus rectum. I feel like a doctor when I say that. There we go. Don't you feel like you're saying to somebody, ma'am, your child's latus rectum scores are... Sorry. Good? And so that's it. We got the graph, got everything. Oh, which equation is right? Oh, we didn't get the equation, did we? Which equation is right? Let me get the equation there. I forgot about that part. I'm getting all into the other stuff. So, which equation is right? Which direction is this thing going? Positive y. Positive y. So it's going to be x squared is positive 4ay. What's the a? Yeah, the a is the distance from the center to the focus, 6. So the a is 6. So x squared is 4 times 6, 24y. So it looks like it's a again. And I'm going to move on. You okay? All right, find the equation of the parabola described. Find the 2 points that define the latus rectum graph the equation. All right, vertex 0, 0, that's the center. Center 0, 0. Axis of symmetry. You guys know what an axis of symmetry is, right? Axis of symmetry, let me put it this way. It spears it. It spears the middle of the parabola. So if it's saying the x-axis is the axis of symmetry. So that means the parabola either goes to the right or to the left. Does that make sense? If the y-axis was the symmetry axis, it would be an up-down kind of parabola. I got to figure out which one. I'll figure out which right or left in a minute. Does that make sense? If the y-axis was the symmetry axis, remember symmetry means same. If it was the same both sides of the y-axis, that'd be an up-down kind of parabola. If the symmetry axis is the x-axis, then that's right-left. Now, which one? Well, they'd give me the point 3,4. So it's got to be to the right, doesn't it? You with me? It's got to be to the right. Over 3, up 4, right there. And the origin, so there it is. It's going to the right. It's going through the point 3,4. And the x-axis is its symmetry axis. It looks like that. What's the equation? Which direction's it going? Positive x. So y squared is positive 4ax. Okay. Now, can I find which one's right? I could just plug in the point, huh? Just plug in the 3,4 point. Yeah, so the other equation's kind of off the screen. So anyway, so is it this one? Is this one right? Because it's one of those two. It's not. It's one. It's either A or B, isn't it? It's either A or B. Oh, wait, it can't be. It can't be B. That's negative. So it's not B. It's not A. It's got to be C, I guess. I guess it's got to be C because D. If you look back at the thing, I think D has got some other reason it's clearly wrong. So the answer must be C. That's the only one with a positive X. So it's got to be C. I'll double. So it's got to be C. It's the only one with y squared with a positive x. So it's got to be C. Got to be c. So the equation is c. It's y squared. Now how they got that, I don't know. I don't have time. We'll do it on another one. So let's just use it now. So last thing, and not an easy thing, now that we have that equation, by process of elimination, now that we have that equation, how do we find the lattice rectum points? That's a little tricky. Yeah, let me help with that. Let me get some room here. Yeah, we've got to find the focus. Exactly. We've got to find the focus. So we've got, this is our equation. Y squared is 16/3 x. So first off, let's find the focus. And then the lattice rectum will just be double the focus points, right? So how do we find the focus points? The focus point, I mean. Well, we got to put a 4 here. Okay, how you guys doing? You feeling sharp here? Hour and a half into lecture? This is a tricky part. This confuses people a lot. But it doesn't have to. Track with me. Think my thoughts with me. We've got it. This is the real equation. 16/3, right? But I have to give it a certain look. Little plastic surgery. Remove the wrinkles. Make it look different. We do so much of math is just that. Giving an equation a new look, but it's still the same equation. That's what I've got to do here. I've got to make this thing look different without being different. What do I mean, look different? Well, I got to have a 4. I got to force a 4. Why? Because then I'll know whatever's next to the 4 is the focus. Otherwise, how am I going to know what the focus point is? Does that make sense? Do you guys see how math equations work? When they give you something like y squared is 4ax, what they're saying to you is they're saying if you get y squared in the front and you pop a 4 here, whatever comes next will be a, will be how far to the focus. So you think, yeah, but I don't got a 4. Right. Make it look that way without actually changing it. Give it that new look. Remove the wrinkles, make it look like that, but you can't just say, oh, you mean just like stick in a 4? Just like 4 times 16/3? No. That would be different. 4 times 16/3 is not 16/3. That's not just plastic surgery, right? That's a different person, right? So we can't do that. So how do I force a 4 to be here, and then some other number, so it's really still 16/3, and then I'll know what the focus point is. 4 times what is really 16/3? 4/3. Because the 4 is over 1. 4 times 4, 16. Now, it's not always going to be that easy. I don't feel that was easy. But what if they'd given me 17/3? What if they'd said, y squared is 17/3 x, force a 4? Well, what would that be? Here's the rule. If you want to force a times 4, then you got to take what you got and divide by 4. And then times 4 will be back to normal. Make sense? If I'm going to force a times 4, then take what you got and divide by 4. And then 4, with the thing divided by 4, we'll go back to regular. So isn't that what I did here? I took 16/3 and I divided the top by 4. And it became 4/3. You with me? How do you divide a fraction by 4? Denominator times 4. Are you good with all those concepts? Here I just did the numerator. Maybe I should bring that up later when we need to. Yeah, I hope I didn't confuse you. So, are we good to there? So, one way or the other, you've got to divide the fraction by 4. Yeah. So there, yeah, I'm probably confusing you more than I need to. So, if you're going to force a 4, and you want it to still be the same, you got to divide this by 4. Boom, like that. Now let me go back to the 17/3. Well, how would I do it with 17/3? If I got to force a 4, you're telling me, Mr. Aaron, I got to divide this thing by 4. So it'll still be the same as it was. How do you divide 17/3 by 4? You can't divide 17. Come on, Pen. You can't divide 17 by 4. Right? You can't do it that way. So what's the other way of dividing a fraction by 4? Stick a 4 in the denominator. When you put 4 in the denominator, what does denominator mean? Divide. Right? So in this case, I would just stick the 4 in the denominator. I would just go times 4, because they'll give you something like this. I don't want you to be confused. 17/12. That's right. There it would be. Does that make sense? You can see it's true. Let me prove it. This is 4 over 1. 4 goes into 12. Back to 17/3. See? It's still 17/3. It just looks different. Everybody see that? Have I lost you? So there's 2 ways to divide a fraction by 4. You can either divide the numerator by 4, if that'll work. That's what I did here. If you can't divide the numerator by 4, just throw the 4 in the denominator. That's still dividing, right? So you got that? So they're going to throw curveballs at you, and you're going to have to force a 4 out here, and that means you're going to have to divide the other part by 4, and that may mean you need to multiply the denominator by 4. All right, enough said. Hope that makes sense. Come see me. These were all confusing for me. I didn't just hear those the first time and just go, ah, yeah, that's so easy. No, it was hard for me, and I had to spend a lot of time getting help and stuff, so I'm glad to help you. Come see me. All right, on we go. So what's 4/3? That is the A, which means that's how far to the focus point. Right? You with me? I know the math is coming on heavy and fast here. 4/3 is how far to the focus point. How far is 4/3? 1 1/3, a little more than 1. So where is it? About right here. Right? Focus point is always inside the parabola. The receiver is inside. So 4/3, right there, inside. 4/3. Okay, great. There it is. 4/3. So where's the lattice rectum points? They're at this depth. Here and here. And how far? Double. Right? Always double. How far to the focus? So double 4/3? 8/3. Just double the top. Only the top. Right? That's how you double, right? 2 times the fraction doesn't multiply top and bottom. It's 2/1. Right? So it's 8/3. Right? We good? So that means this, so it goes up 8/3 and down 8/3. I'm kind of running out of room here. This is at 4/3, down 8/3. So the lattice rectum points are going to be then over 4/3, up 8/3. This one's going to be over 4/3, down 8/3. There we go. Just as easy as that. That's kind of a pain, huh? So there we go. So everybody sees. So recapping, what did I do? I took the equation, y squared equals 16/3 x. I said I got to force a 4 out here, so divide this by 4. That told me where the focus point was. 4/3, always inside the parabola. And then double that, 8/3 up, 8/3 down for the lattice rectum points. Questions? Let's see. So there we go. So we got a vertex and we got a focus point. Okay, so are you guys okay with that noise out there? Is that okay for you? I mean, I could say something, but if you're fine, I won't. Is all good? All right, let me know if it's a problem. All right, so vertex negative 4, 1. Those are just my students for the next class, and they're excited. They're probably talking about math, I'm sure, right now. All right, so vertex negative 4, 1, focus negative 5, 1. Can you find those points? So let me let you put those on the graph. One, 2, 3, 4. Oh, not up 1. Huh? I forgot about the up 1. So right here, back 4 up 1, and right here, back 5 up 1. Oh wait, I need more room. I gotta move this over. Didn't realize it was all on the left like that. So 1, 2, 3, 4, 5, up 1. So right here, minus 4 up 1. That's the vertex. That means the center. And minus 5 up 1. That's the focal point. Which way does this parabola go? So this one is not centered at the origin. They're starting to move them on us. Which way does this thing go? Up, down, right, or left? Here's the center. The vertex is the center. So it goes to the left, doesn't it? It must go this way. Because the focus point is always inside the satellite dish. Good? Okay, so it's going left. So what's the basic equation? So now take the direction, write the direction, and write the basic equation. It's going in the negative x direction, isn't it? So it's going to be y squared is minus 4ax. Good? What's the A? A is how far from where? The center to the focus. So A is not the focal point itself. Now this is a good point to stop and clarify something you might have thought wrong. now that we're moving them. A is not the focal point itself, it's how far to the focal point. So how far from the center to the focal point? 1. That's just 1. Don't worry about -1, +1, whatever. We know it's negative. We already got the negative thing. A is 1. You guys with me? A is how far from the center to the focus. So A is 1. -4 times 1 times x. Finally, this one is not centered at the origin. What's his center? Right there. Here's his x value and his y value of his center. And what do you always do with the x value and the y value when they're not 0, 0? In the equation, I mean. Opposite, opposite. Right? So that's going to mean, instead of x, it's going to be x plus 4. And instead of y squared, it's going to be y minus 1 squared. And there's our equation. Everybody see that? Because y has a positive 1, so opposite would be minus 1. X has a negative 4, so opposite would be plus 4. So there's the equation. Y minus 1 squared is -4 times 1 times x plus 4. I'm sure that's up there. Grab it. That makes sense? Questions? Okay, so focus, -4, -2. So there's the focus. Negative, back 4 down 2. So there's the focal point. Go ahead and put the directrix line on there. Remember, it's a line, not a point. Put the directrix line on there. So the directrix line is at x equals 6. What does that mean? It goes through the x-axis at 6. 1, 2, 3, 4, 5, 6. So there's the directrix line at x equals 6. Good? So where's the center of this parabola? Now they're getting more tricky on us. They're not telling me the center. Where is the center? Well, it's right in the middle of those two. Remember, the center is always right between the directrix line and the focal point. So we know this parabola is going to the left, isn't it? Because the directrix line is always behind it and the focus is... So it's somewhere in here, going left. But where exactly? Well, it's going to be on this line. But where exactly? Well, you got to find the middle. The middle of what? The middle of -4 and +6. How do you find the middle of -4 and +6? Or you might be able to tell this one just by looking, but they're going to give you 27 and 86. Something like that. That's dramatic. But anyway, they'll give you two numbers you can't just tell by looking. So you need a general game plan for how you find the middle of two numbers. How do you find the middle of two numbers? Yeah. How do you find if you got an 80 and a 90 on your exams? How do you find the middle? It's called the average. You add them and divide by 2. That's how you find the middle of two numbers, huh? You know that. Add them and divide by 2. So you just take, so the middle will be -4 plus 6 divided by 2, which is 2 over 2, which is 1. So right here, 1. 1 is the middle of -4 and +6. Yeah, that's right, isn't it? It's 5 that way, 5 that way. 1 is the middle, isn't it? Does that make sense how we found that? So it's got to be right there. So the center has got to be over 1, down 2. It's got to be on the down 2 line, you know, lined up with the focus. Does that make sense? See how it's lined up with the focus? At over 1. So there's the center, and it's going this way because the focus is always inside the parabola. Good? Now can you write the equation? So write the equation. Which direction? Which direction is this thing going? Negative x direction. So it's going to be y squared is minus 4ax. It's the general look. And what's a? A is always how far from the center to the focus. That's a. How far is it from here to there? From the center to the focus. Just count them. Just count them on your graph. 1, 2, 3, 4, 5. A is 5. So A is 5. So we get y squared is minus 20x. Good so far. It's 4 times 5, 20. And it's minus because it's left. Am I going too quick? That's good. Last thing, it's not centered at the origin. It's centered at, here's the center right here. So remember what you do? Here's the x, here's the y, opposite, opposite. So y plus 2 squared, x minus 1. There we go. Whatever one that is. Is it B? Yeah, B. There we go. Good on that? That okay, how I pieced that together? I make it look easier than it is, like, just because I've done it 10 million times. So for me, it's like tying my shoe now, but it was not the first time I did it. I thought these were super hard. So make sure you do this on your own, I'm kind of prompting you through all the right questions to ask. So you need to learn to do that for yourself. So practice this on the homework. So they're giving me y plus 1 squared is 6 times x minus 5. Y plus 1 squared is 6 times x minus 5. All right, so they want me to graph it in the end anyway, so I would suggest, I think it's easiest and most helpful just to begin graphing right away. Because having a picture to look at is just helpful. So go ahead and start. So how do you start? What's the center? Can you look at that and know what it's always good to start with the center. What's the center of this thing? Can you tell? Remember, it's the opposite of what's next to x, opposite. Remember, from equation to center are opposites, right? So many facts about these to remember, huh? So the opposite of what's next to x, opposite of negative 5, positive 5. Regular 5. Opposite of what's next to y, negative 1. So 5, negative 1 is the center. 1, 2, 3, 4, 5, down 1. There's the center. Good to there? Okay. Which way is this thing going? Right, left, up, or down? First power letter tells the story. Positive x to the first. Positive x. It's going to the right. Good? First power letter tells the direction story. That's the most important thing to know about parabolas. Which way are they going? Right, left, up, or down? Is that good? See how I got that? Okay, now they're going to ask me for the focus point. How do I find the focus point? It's time to do plastic surgery. Right? Remember, to find the focus point, you've got to force a 4 to be out there without actually changing anything. You got to take that 6 and force a 4. That's weird. How do you take a 6 and force a 4? Well, if you're going to multiply by 4 and you want to not change anything, then you've also got to divide by 4. I'll reduce that. That's 3 halves. But everybody see that? That's still a 6, right? These 4s will cancel. That is still 6. It just looks different. It just has the look I want without being different, right? That makes sense? And then just reduce that thing to be 3 halves. And so that's my A. That's how far to my focus. Everybody see how I do that with the A? Right? I take the 6 and I do 6 and divide by 4. Because I'm multiplying by 4. So that's what you always do. When you're forcing a times 4, you divide by 4. So nothing's changed, really. So then reduce it. So A is 3 halves. 3 halves is 1 and a half. 1 and a half. Right, you with me? 3 halves is 1 and a half. So 1 and a half where? Well, where's the focus? It's always inside the parabola, huh? So I got to go 1 and a half to the right here, the focus point. It's 3 halves to the right. Everybody with me? From the center to the focus is 3 halves, isn't it? Now they're going to ask me for the coordinates of the focus. So instead of 3 head, here, let me fix this a little bit. So plus 1.5. Or let's just make it a decimal. How about 3 halves is 1.5? Let's just do decimal, that'd be easier. It's 1.5 to the focus, isn't it? 1.5 to the right to the focal point. So I'm adding 1.5 to what? To the 5, to the x coordinate, exactly, because it's 1.5 to the right. It's not up or down. It's right. So that makes it 6.5, negative 1. So this focus point must be 6.5, negative 1. They're going to ask you for the coordinates of the focus point. 6.5, comma, negative 1. So that makes sense? 1.5 to the right. And do they want the lattice rectum? No, good. They don't ask for those. I won't bother with those. Where's the directrix, though? They're going to want the directrix. Remember where the directrix line is? It's always behind the parabola. Same distance as the focus, just other direction. So if the focus is 1.5 to the right, directrix line is 1.5 to the left. So if you go 1.5 to the left, you'll get the directrix line. So where would that be? Well, this is at 5 right here. So if you back up 1.5, 5 minus 1.5 is 3.5. So you're right here at 3.5. At what? X equals 3.5 is the equation of the directrix line. Everybody see that? How I did that? From the center to the focus and directrix are same distance. The center of the parabola sits right in the middle of the focus and directrix. So it's 1.5 to the right for focus, it's 1.5 back. So from 5, subtract 1.5, it's at 3.5. My 5's leave a little bit to be desired. And I think that's everything they wanted. They wanted a lot. That's everything. We good? So number 15. So we've got y squared minus 10y plus 3x plus 25 is 0. It's probably our last one here. We're in 15. Okay. How do we do this one? Y squared minus 10y plus 3x plus 25 equals 0. Well, they want me to graph it and all that stuff. Notice it's not in right format. What do I mean? Back over here, see how this one had something squared? That's what you need. That's right format. You got to have something squared in order to do all the stuff we've been doing. You got to have that look. Plastic surgery again. Big fancy plastic surgery. We got to give it that look. Got to remove the wrinkles and give it that look. This right here needs to be transformed to have that look. That parenthesis squared look. So let me write that. Must have. Yeah, so all we're going to have time for is to finish this one. Must have parentheses squared. So what does that mean? Well, first off, yank this stuff to the other side. Why? Because see how we always have y on one side, x on the other? Where we separate them? So I'm doing that. So we got y squared minus 10y. Move these guys over. Minus 3x minus 25. Good so far? Now, how do I make this stuff have like a y plus some number, maybe minus, whatever, squared? How do I do that? How do you transform this to look like that and yet not be any different? That's a fancy plastic surgery. Removing those wrinkles, how do we do that? Well, do you remember it from algebra? Probably not, I assume. It's called completing the square from algebra. Anybody? Nobody? It's all right. You take the number that's in the middle. Here's it's like a magic formula. You take that number over 2 and square it. Negative 5 squared, 25. And you add 25 to both sides of the equation. Because I'm bringing in a new 25. I've got to do it with balance. I can't just write 25 on the left side. I would change the problem. I've got to add it to both sides. So I haven't changed anything. I've just given it a new look. You with me? Now why? Why does that work? Because now these three will factor perfectly. By the way, the other side is just minus 3x now. How did these three factor now? Y minus 5, or y minus 5 squared. See how it made it? It transformed it to have that look? There is one of those on the test. You have to learn to do this. This is called completing the square. It's an important skill. To see what I just did there? Now I'm ready to do all the other work of graphing. Now can I go dot, dot, dot at this point? Now you draw the graph, find the focus, directrix, all that stuff. That was just the setup work right there. All right, well, we covered a lot of math.